Thank you everyone for joining. Appreciate you taking some time and willing to spend the next 30 minutes with Jim Shaw, our Director of Simulation at Boston Engineering, and I feel like you'll be learning a lot today. It's John Driscoll, General Manager for Boston Engineering, and own our relationship with Ansys. Have become a partner officially in January of 2020, but have been using Ansys solutions for decades. So excited to be partnered with them, and excited that you guys are on the call today. It's critically important to understand, many of you on the call today are designers looking to get better insight into your designs, design better products, meet your product goals. Boston Engineering is a consulting product development company. Has a lot of internal designers and engineers as well internally that are designing products, not only in commercializing some of our own technology, but supporting a number of different customers in defense, security, medical, and many different industries, bringing their products to market. And simulation is critical to that. So today we'll be focusing on Discovery, which is a great product, purpose-built for designers, to give you guys that insight, and obviously with certifications and looking to reduce prototypes and kind of improve the design process, help you get your product to market faster, helping you reduce costs. Those are all part of the reason you look at simulation, to drive value in your organization. So and we found is that many of our customers, we've been a longtime PTC customer, and many of them are also using Ansys as well. So it's been a great, from a maturity standpoint, helping our customers not only with software or training or potential services, ultimately making sure that you guys are successful with these tools and technologies. So excited to have this partnership, Boston Engineering, between PTC and Ansys. They have a strategic partnership as well. But many of you guys today are in multi-CAD environments, and the nice thing with Ansys is it is agnostic. So we're excited to engage, just like Boston Engineering uses many different product development tools and mechanical to design products for our customers. Ansys plays nice with all of those. So if you guys are in those types of environment, as we are, I think Ansys plays a great opportunity, and it's really kind of helping you guys get that insight and start at the right level from a designer's perspective. So with that being said, I'll transition over to Jim, and thanks for spending your time with us today.
Awesome. Thank you, John. You hear me okay?
Yep, you're great. Thanks.
Fantastic. So yeah, we're going to spend the next 30 minutes digging into the brand new tool from Ansys called Ansys Discovery. So I think if we're familiar with some of the Ansys software that's been out for a while, we heard of the flagship products, Mechanical and Fluent, as well as Ansys Discovery Live, which has been out for a few years, running on GPU, and then Ansys AIM. So what we're going to talk about is the newly released Ansys Discovery, which came out just a few weeks ago. In fact, we're leading the official Ansys launch, I believe, is a week from today or a week from yesterday or something. So we got a little bit of a special approval to run this. So I had to get everything approved, and we're good to go. What we're going to do today is walk through the new interface. There's a new interface that has been designed for the Discovery product. We're going to be doing a thermal analysis on electronics. This is an area that we live in very, very regularly on a daily basis, and hopefully it resonates with those who are watching as well. We're going to show how to do quick design updates and show how to track performance trends, all within the same environment. We're going to be talking today about GPU versus CPU solver technology, because we get both in the new Ansys Discovery tool, which is new. And we're going to certainly be talking about a topic that we talk about all the time at Boston Engineering, which is speed versus accuracy. When do we really care about doing quick flips, if you will, on simulations? We don't want to wait for the mesh. We don't want to wait for convergence. And when do we really care about, okay, we need to get a number that we can correlate to test data, or that we can confidently make design decisions based off of. So, and then at the end, we'll do a little Q&A. Okay, so before I jump in, I want to have a quick discussion about what the landscape looks like for the Ansys portfolio of simulation tools, and how it's changing, and why Discovery is such a big deal. So yesterday, if you will, or all the way up until the new release of Discovery, this is, in a nutshell, what the portfolio looks like. And those of us who have joined us for some of the previous webinars will recognize this, but basically we have a full portfolio, full suite of software, whether you're looking for speed, so Discovery Live, which is a technology that's been out for a few years now, runs on the GPU, so it runs on our graphics card, so we're getting solving and post-processing all at the same time. So we literally get near instant results. Granted, they are not the most accurate, but there are many times where we just want to look at design trends, high-level things, make big changes, right? Then we've had the Discovery AIM product out for quite a while now. That is a product that under the hood is solving with CPU technology, very, very similar to the mechanical and fluent products that have been out for decades. And Discovery AIM was really targeted for those who are relatively new to simulation. Its interface is more innovative, a little bit cleaner, I should say, a little bit more easier to kind of follow than mechanical and fluent, where mechanical and fluent and the workbench interface is meant to really dig deep and have all the options, and can be very intimidating to those who are relatively new. And then of course, when you want absolutely 1% or 0.1% error between your simulation and your test results, you're going into the flagship products, right? So we're looking at the workbench environment within Ansys. We're doing mechanical for FEA, fluent and CFX for CFD, HFSS and Maxwell for our electromagnetic and simulations. And we have scripting and coding, and you can dig so far deep that you basically are able to find and remove any of the numerical or physical error that you might have in your analysis, okay? So, but there are times where we might want to have the quick for live, the mediocre, if you will, or somewhere in the middle between speed and accuracy for AIM, and the deep dive in mechanical and fluent. So this is what the layout of the portfolio was before the new release of Discovery. This is what it is starting today and moving forward. And so the new Ansys Discovery tool is going to play the role, if you will, of what Discovery Live is. Discovery Live is still available, and what Discovery AIM is. And Discovery AIM is still available, but the new Discovery, and what's been obvious to us and obvious to those of us who are watching the whole thing, the lot of investment has gone into the new tool and to combining both the GPU-based technology as well as the CPU-based technology, okay? So what we've got in the same, it's a brand new interface, in that same single piece of software, we're gonna get GPU solving, quick speed, not so much accuracy, and we're gonna get the ability to use the mechanical and fluent and CFX solvers under the hood, but within that environment. When we're ready, we want to go to the nth level, we can always export the model and go into our core solvers, okay? The new Discovery product has several stages. What we're going to see here in a second: model, explore, and analyze. And so as we sort of navigate through these three stages, and we're in the explore stage, just think explore means quick explorations, quick discoveries. I'm looking for speed over accuracy when it's time to truly analyze and get a hard number that I want to correlate to test data or show my boss or convince my customer that things aren't going to break. I'm going to be in the analyze stage. So what we're getting right now is, again, a brand new interface, this three-stage workflow: model, explore, and analyze. Model is our geometry modeler, so that's space claim, direct modeling, direct editing, quick, easy changes, very intuitive, no history, no sketching. Well, we've got sketching, but there's no sort of traditional parametric sketch-based stuff like we'd be used to in, say, Creo, for example. We've got the explore stage, quick analyses, GPU-based, and then we've got the analyze. And we're able to seamlessly transition from one to the other. So no matter our task, we can slide back and forth easily. And then brand new tool from 2 weeks ago, but we come with a full range of physics, right? So this is certainly not Ansys's first time releasing new simulation software, so they're certainly not going to release something that is really, really trimmed down. So we've got structures, fluids, we've got heat transfer, we've got modal analyses, and we've got topology optimization. And we can mix the two, right? So we've got thermal stress for thermal and for structural, and we also have conjugate heat transfer for fluids and thermal. So we can do natural convection, forced convection, things like that. For topology optimization, there are some industries that this is all they talk about. There are other industries where it hasn't quite hit yet. But the big question a lot of people have in top opt, as we call it, is, can I get usable geometry when I'm done? And the answer here is yes. So right out of the box within Ansys Discovery, I can do my topology optimization, I get my faceted body, and then using space claim, I can get my my solid model, right? Goes right back into my CAD model or right back into wherever I'm doing, whether it's machining, 3D printing, or whatever. So, okay, just before I jump in, again, 3 stages. This is kind of a new workflow. First stage, modeling, I'm making my design changes. Second stage, explore, I'm getting immediate results, looking for design trends. Third stage, analyze, I'm getting my more accurate answers because I have the ability now to manipulate my mesh and tweak my convergence and things like that. So let's jump into the interface. I'm going to come out of that and I'm going to open up. So this is the brand new Ansys Discovery. When you launch it for the first time, we're going to get a nice splash screen as we always do. And I know what you're going to do. You're just going to hit the X and keep going like you do with all the other software. And I would urge you not to do that because when you pass through here, I'm just going to pause this. Some nice videos play, but because this is a slightly new workflow and this is a new GUI, a new graphic user interface, there's some nice helpful stuff here. So we've got the 3 stages, we've got an overview of the UI, we've got some navigation. This is pretty typical. I'm sure a lot of us have spent quite a bit of time in CAD, so we're familiar with the button clicks, all the different tools that are available, and then the help. And what's really innovative is there's an interactive help that overlays on top of the interface. So again, and I hate to say this because I've been training engineers and designers in FEA and CFD for 10 years, and this really pains me to say, you don't need training with this. So the real key differentiator right now with Discovery is the learning curve has been shortened. I'm not saying it's going to instantly give you 10 years of experience, but it is going to allow you to start to get results, to aid you in design decisions, and you can do that all without having to take a training class, which is fantastic. I mean, that's really the purpose here, is whether you're coming from another, say, CAD embedded tool, or it's your first time in simulation, or you haven't seen it since college, which we hear quite a bit. It's going to walk you through every single function. And as you can see here, setting up a force, there's a little paragraph there on some best practices and techniques that you want to use when you're setting up a force. So the interactive help is really, 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 really cool. So anyways, don't just kill the splash screen. I'm going to close out of this and I'm going to open up some geometry. So from just my open dialog box, I'm going to grab my geometry. Now, because we've got space claim, we're able to open any type of CAD geometry. So whether you're coming from SolidWorks or Creo or Inventor or whatever, you can automatically directly input that file. I don't need to go to an IGES. I don't need to go to a STEP or a Parasolid. I can bring it in natively. I have a space claim file called router, and I'm going to hit open. Now, because I'm not opening a Discovery file type, I'm actually opening a CAD file. It has to do a quick conversion, right? So we're just going to wait just a second here and open up. It's going to convert all of our assembly geometry into the Discovery format here. So in the bottom left-hand corner, you can see it says translating geometry, and now we've got our assembly. So this is just a sort of a consumer router. We've got a plastic shell, we've got a case, we've got 4 antennas, and we've got some electronics underneath that we're going to investigate here in a second. So I want to do a quick walkthrough on what's kind of new in the user interface. For those of us who have used Discovery Live or CAD or really any program now, I think Microsoft Office came out with it way back in the day, but the ribbons are all there. They've got icons and drop downs, and you can dig in and see all the different types of physics and boundary conditions and loads that we can put on. But that's not really what's cool. What's cool is the new interface in the graphic screen. Really, where we see the trend of software going is to focus on the graphic screen to create an interactive and rich experience. And you're seeing that with a lot of the CAD tools now, right? So we don't have to have a lot of, as you say, mouse miles, right? I'm not moving the mouse cursor all over the screen and getting wrist pain or whatnot, especially since we're working at home a lot nowadays. I want to keep my mouse tight to my geometry. I want to do all of my stuff interactive here. So embedded in my graphic screen, I've got my trees. So these are pretty typical, right? I've got my geometry tree here, and I've got my physics tree. So here we've got a case, we've got the electronics and the antenna, and right inside the tree, I can turn these off and I can just hide them from the graphic screen. The other thing I can do right next to that is remove it from physics. So I can immediately just take that right out of the equation. I can remove the antennas and then I can hide them. And what's really cool about this is I'm actually able now to bring in my production CAD, right? All of the geometry, all of the little details. I don't have to spend so much time in CAD doing my pre-processing and doing all this stuff. I'm just gonna bring it right into Discovery. I'm gonna remove what I don't care about or I don't wanna look at right now. I'm gonna hide it from the screen, and now I can focus on what I really wanna focus on. So in this case, I'm looking at my electronics. What do I have? I've got a heat sink. We can see that extruded aluminum heat sink on top. I've got a circuit board. with sort of a thermal pad, and then I've got my microprocessor or my microchip there. So as I set up an analysis, once I've got my geometry squared away, the next thing I want to do is my materials. And so you can see in my physics tree here, everything comes in as a default structural steel. So what I'm going to do is I'm going to change them to materials that actually are correct. And so interactively, I'm just going to triple click. And as I do that, I highlight the whole body. Now, when I do that, you should notice I've got two icons floating above my geometry here. These two icons represent the upper right-hand corner and the upper left-hand corner of what we call the HUD, or the heads-up display. So it's kind of like, like a brand new Corvette or a fighter jet, right? I'm displaying some dashboard, if you will, in an area that I'm always going to be looking, so I don't have to take my eyes off of the road or, something less critical like simulation geometry. Upper right-hand corner, I've got my displays, so I've got colors, and I've got transparency. And then the upper left-hand corner, you notice that, oops, double click again, I've got this hex icon. When I click on the hex icon, I get a new GUI option here, which is our halo. So inside the halo, this is really all we need. This is about 90% of the functions that we need to do our job. I don't have to come up into the ribbon at all. I've got three categories of tools. I've got my simulation down here at the bottom. I've got my selection tools. And as I change these selections, I get my new sort of tool set around the outside. And I've got my modeling. Okay, so I've got simulation, I've got my modeling, and I've got my selection. Here, I'm going to change my material. So I'm in simulation. I click on material. And I'm going to change this extruded heatsink to aluminum, so 6061 T6. So as soon as I do that, you can see I've highlighted that. It's been added to my physics tree, and I've got a nice green display for my heads-up display telling me that everything looks good. So I'm kind of in this material heads-up display now, and so I'm going to select on my circuit board, and you can see that it's highlighting as structural steel. If I wanted, I could go over to the right-hand side, and this is the entire Granta material database. So those who are Ansys users already will know that Granta has a massive hundreds and hundreds and hundreds of material database. And so I can just come in here and grab this and say PCB, and I'm going to go to a FR4. Grab this guy right here. Okay. Underneath, I've got a little pad. I'm going to do the same thing, and I come back over here, material. There's my PCB. I can favorite those materials so they always show up in the interactive halo. And this is a microchip, and I'm just going to make this copper, which is a pretty common assumption that we do sometimes. Okay, I've got my material properties set up. Structural steel is still shown because that's kind of pulled into memory, but I have no materials applied to it. I'm just going to hit escape a couple times and come back to sort of an empty screen. I've now kind of backed out of that HUD display. And by default, as I opened up Discovery, I have come into the explore stage. And if I were to lean to the left, I've got my model stage. And if I lean to the right, I've got my analyze stage. If I were to go to model, all it's really going to do is bring me back to my design tab, which has all of my space claim capability, my geometry capabilities. But I don't really need to do that right now. What I'm interested in doing is looking at what the temperature profile is on this. And so now that I've got my material properties, I have to add some loads. And again, I'm not going to go up into the ribbon. I'm just going to triple click, 1, 2, 3, go to my halo, go to my simulation. And right here, I've got my three physics. I've got structural, if I were to do a structural analysis, fluids, if I were to do a fluid analysis, and thermal. I'm going to go to the third icon and add a heat load. So 25, and then it defaults to watts. That's the units that I've got. And then, of course, if I wanted to, I could start typing in other units on the fly, which is relatively common nowadays. But for those who have been working in Ansys for quite a while, this is a really nice luxury. As soon as I did that, a couple things happen. Number one, I have heat added to my physics tree. And secondly, I have a new icon down here. So this right down here is called the SID, or the Simulation Information Display. And this is really giving me a dashboard of the physical side of things, right? So I've got my HUD, which is my heads-up display. You can see it's right now locked in on loads and boundary conditions for a thermal analysis. I've got the halo, which is my shortcut for all of the things that I really need to do. And then I've got my SID. Let me just escape out of that. So the SID shows me a hexagon. It reminds me which physics I'm about to solve. So in this case, I'm going to solve a steady state solid thermal analysis. If I were to do any sort of multi-physics, like I were to add in structural constraints, I would do a thermal stress analysis. All of that's going to kind of update down here and remind me. Here we're being reminded that I've got a steady state analysis. And then the fact that this surrounding is yellow means I have not solved it yet. If I hover, you can see it says not started. So because I'm in Explore, I'm in the GPU, I can slide my fidelity back and forth. This is just an accuracy or a fidelity related to the GPU and how it's doing its meshing and its discretization. I'm going to leave it at the default, which is somewhere down to the bottom, so I can get some quick results. And I'm just going to hit the solve button here. And since we're on the GPU, we're post-processing and solving it all at the same time. And I have basically results right now. And so if I look at some newer things in my user interface, I've got my view arc down here. So these are all very common sort of CAD manipulation. I've got my graphics, I've got my preset views. On the right-hand side, I have my simulation arc. And so I've got my results, I've got ISO surfaces, I've got some particles and vectors if I was doing a fluid analysis. And then inside here, I've got show mesh. This is grayed out right now because I'm on the GPU, I'm in Explorer. I don't have control over the mesh except for this fidelity slider. So that's grayed out. I've got my monitors, which we'll talk about in one quick second, and I've got cut planes and whatnot. I can animate, show deformation. But right now, this is a thermal analysis, so I don't really have any physical deformation. Another thing that we have in the display here is everything is going to be movable, so it's very customizable. You know, I can take my physics and I can kind of slide this up. I can slide up the router or the model tree here. But in the upper right-hand corner, I've got my monitor, and so by default, I've got and think of a monitor as basically a sensor, right? So think of this as a temperature probe that I put on my assembly. So if I grab my max temperature, I'm going to slide this over here, and I look at a graph. This is the first iteration, if you will, the first analysis. And I can see that the max temperature that I have is right around 104, 105 degrees Celsius, right? And we can see that here in our legend. If I flip this over, we'll see what we all probably expected, which was that microprocessor at 25 watts is really kicking out quite a bit of heat. So as a designer, I'm always looking for ways to make the design better. So for this case, the first thing I'm going to do is go back into my geometry. So I'm going to pause the analysis here. And that's just to save my GPU from running. I'm not making any major changes right now. I'm just going to pause it. We'll do a live edit in a few seconds. But from here, I'm going to stay and explore. Okay, let me slide this over, zoom in a little bit. I'm staying in Explore. I've got my analysis paused. I'm going to go back over to my model tree, and I'm just going to expose and turn on some of my geometry. And again, this is a great way to give us context. It's a great way to show investigation on a subassembly, but really we're always talking about the system level. How does this subsystem work in the larger piece? And a lot of times what we've had to do in the past is strip out our geometry just to bring it into the analysis tool. And sometimes when we do that, we lose some context. By doing that, I see a pretty blatant issue here, which is I have an interference with the extruded heatsink in the case. And so I'm just going to make a design change here. Another thing I can do to look at that is I can do a cross section. And to do that in this tool, I'm just going to grab my coordinate system for Y. I hit X on the keyboard, and I'm in cross section mode. And now I grab it and I can kind of slide it in. So this is all very much interactive. I can stay in cross section mode and take a peek and just remind myself, yep, there's an interference. I hit D to come back out of cross section mode. And what I'm going to do is I'm going to take the top of this fin and select it. And I want to select all the fins. And what I want to do is I want to use the geometry modeler to make them shorter. And all I've done is select one. I've got a power select down here, which I really like. So I go to power select and I grab all coincident faces. What that did is it grabbed every single face that was on the top, and I now have it all selected. And I go up into my HUD, into my halo. I go to my modeling. I go to pull, and I just drag it down. I drag it down about, call it 12 millimeters, and I come out of that. My advanced selection, hide that a little bit. If I were to go to my cross section and take a look at that, I could see inside. I pulled it down, got some clearance. Let's go back in and just hit solve again. I'm still in Explore, so I can still hit solve. Let's get the case out of the way. Let's get the antennas out of the way. And then let's take a look and see what happened. And as we can see, as we would have expected, by removing the height from the fins to remove that interference with the case, our temperature's gone up. And again, this is a solid thermal analysis. I am accounting for heat loss into the environment using a convection coefficient, which is very much dependent on the surface area. So I made my fins shorter, I reduced the surface area, I now have less heat loss into the environment, and so my component goes up. This is unacceptable. When I fix the design, I want to have my component go down, and so I'm solving right now. I have a green circle or a green hex around my SID. And so actively while in here, in my explore mode, I'm just gonna come into my pad and I'm gonna triple click 1, 2, 3. That grabs that whole piece. I'm gonna go to my halo in my heads up display, grab material, and I'm gonna change that to copper. And that's essentially like modifying the printed circuit board to have more conductivity. As soon as I do that, and this was all live, I instantly change my results and I can see quantitatively what that does to my component. So all good stuff. Again, this is a very, very interactive. I haven't left my 3D environment, and I've got my graph, I've got my monitors, I'm looking at my design trends, I've got access to all of my modeling tools from my Halo. So I'm really focused on what am I doing and why. All the while I'm solving on my GPU and getting those instant results. So we're gonna do one more edit here. So I'm gonna go and just take a peek. This case has and I'm not quite sure what this is. Maybe it was the industrial design team. They said, hey, we have to have a little V in the middle. And I think to myself, quick tolerance stack. I wanna make sure that these 3 in the middle do not interfere. And so escape out of that. I'm gonna grab that surface. I'll control select these 3 surfaces. Notice how my heads up display is kind of readjusting to the selections I have. And again, I'm gonna go into my upper left-hand corner into the hex, into my halo, into my modeling, grab my pull tool, and just bring these down just a hair. I hit escape too many times. Okay, so again, I'm making near instant direct geometry modeling changes, and I'm getting practically instantaneous results. But I know that on the GPU, I'm not exactly accurate, right? What that means is if I were to bring this to my boss or my superior or my client or my customer or whoever and launch this to production, how confident am I in that 47-degree number? Not very confident yet. And the reason that is because I don't have any control over the mesh. I don't have any control right now, really, except for a slider down here over my numerical accuracy, right? And so when I'm ready, and I've done 4 iterations, I've done material changes, I've done geometry changes, I'm ready to go and to actually truly analyze this. So all you have to do is slide over to the analyze mode. And what this does is bring you into a full-blown, I'm using air quotes, CPU-based solver. This is under the hood Ansys mechanical because I've got my solid structural analysis. If I were a fluid flow, this would bring me into Fluent under the hood with the brand new GUI. So what lit up in our ribbon, I now have access to my fidelity controls, global mesh controls, my local mesh controls. So for those of us who are coming from either other, say, CAD embedded tools or other Ansys products, you're gonna be very familiar with managing the mesh. In addition, down in my simulation circle and my arc, I also have the ability to show the mesh. And so now what I do is I go through my my workflow for adding some mesh controls because my experience tells me chances are when I get answers really quick, it means I have a mesh that's too coarse. And so I'll show you how I would add a local mesh control. So again, triple click, 1, 2, 3. I've now selected the entire a body for the fins, and I'm gonna go up into my halo. I'm gonna go to my simulation, and I'm gonna go into, not my halo, I'll go to my local. That brings it up in my HUD. And then I can grab and say, for example, like 3 millimeters, and I just type in millimeters and I grab it. Okay. I'm not gonna hit solve here, because if I hit solve, this is gonna engage the CPU, and I'm sitting on a pretty small laptop. I only have 6 cores. I only have 4 gigs of GPU RAM, which is pretty much the minimum that is required for running the software. So if I already hit the solve button now in the analyze mode, basically this is going to start to go around, and it's gonna take probably about 10 minutes to go around. Halfway around, I get to see the mesh, which is again available in the CPU, and then the other half has to solve. So thankfully, for the purpose of time, I have another one open. And so this is the same exact geometry, the same exact model that we ran previously. This is the analyze mode. So I'm in a true CPU solver. I have true access to my mesh, and I'm able to add my local fidelity settings, if you will, or a local mesh refinement. And I'm able to see what happened to my max temperature. So if I kind of slide this over, and pull this out a little bit bigger so we can see it. But what you can see is, as I'm making big design changes, right? 10, 20, 30% differences in the temperature. I want a GPU solver. I'm making big changes, geometry changes, material changes. When it's time to get a little more accurate, I want control over numerics, control over conversions, control over my mesh. Then I use my analyze, and I've got my purple triangle there. And you can see that when I went from a quote unquote less accurate speedy GPU, I was at 70 degrees C for my component. And when I went to my true CPU-based solver, I'm at 74. And this model's not done. I have quite a bit more work to do if I were to bring this even further. So you can see I've got some mesh controls that are probably missing. I would need a much finer mesh on the component, and certainly through my circuit board, because I've got a lot of heat transfer happening in the footprint there. This would be the bare minimum. I'd probably want to add at least another element through the thickness here. And I would probably, 6, 7, 8, 9, I'd converge on some value, maybe it's going to be 76, 78, something like that. And then I would sit down with my team and say, okay, this is what we know. This is where we're at. How are we doing? And if anyone on the team knows much about electronics and electronics cooling, the reality is doing just a solid thermal, conduction, if you will, analysis is really just half the story. The true story is, how do we lose heat to the air? And so what I would do next is I would create a new simulation. So I could go in here and say new. I'm not going to do that because it's going to take a little while. I'll hit new, and I would set up a fluid flow analysis. And then I would use my design tools, and I would prepare. I would do a volume extraction or enclosure. I start adding air around this assembly, and I would continue to move forward. And as we did that, we would continue to see a convergence on a true value. If we wanted to go beyond that, for example, non-linear, transient, radiation, anything really deeper into the physics of the actual truly what's happening, at any time I can take my analysis and I can export it directly into mechanical or directly into Fluent. So that in a nutshell is us kind of walking through a true, I think, a realistic journey, if you will. So kind of go back to the slides here. Let's pick up live demonstration and the recap, go to reading mode. So recap on this slide. The recap is this. What we just did in less than 30 minutes was use the model stage to fix an assembly interference, use the geometry tools being driven by space claim to make sure that the design is going to meet whatever design requirements we have. I'm using the explore stage, so my GPU-based solving, to do a quick material sensitivity study or a sensitivity analysis. I'm making some bigger changes and I'm seeing what happens to the temperature. But when it comes down to brass tacks, I want hard values. I want to correlate to test data. I want to have confidence in my numbers. I slide over to analyze and I start focusing on my mesh density, my accuracy, my numerics, my convergence, things like that. So in a nutshell, that simulation journey really looks like this, right? It's really what is important about the design. In our case, it's the operating temperature of that microchip. That's directly related to the reliability of our electronics. And so for the first part of the journey, we're making really, really quick changes. We want to innovate. We want to try goofy stuff. We want to try stuff we've never tried before. But if it takes too long to wait for an answer, then we don't have enough time to try the really crazy, innovative stuff. So let's just look and use a GPU solver. It gives me an answer very quickly. I know it's going to be good to within maybe 15, 20%, depending on the physics, but that's all I'm looking for right now because I'm making big decisions, right? How many fins, how big's the, what's the material involved with the heatsink, everything. When I'm ready to get serious, when I've narrowed down all the crazy ideas and I'm into the really good ones, I want accurate answers. I want to be confident that I'm not going to break and test. I want to be able to move forward with confidence. I slide over to analyze and I do a couple iterations. We've only done one, but I do a couple iterations on mesh sensitivity and my numerics. And that's going to give me the confidence that we're exactly where we want to be. And again, under the hood, we're being driven by mechanical and fluent. So it's really easy for us to just export it right out. And whether we are knowledgeable in fluent and mechanical in the workbench environment, or we're on a larger team, right? So maybe my role isn't an analyst. I don't sit in the numbers all day. My job is to get it really close and then hand it off to those guys. The new Ansys Discovery makes that handoff absolutely seamless. It's amazing. Okay, so that's the video. That's a little bit of the process. I hope it kind of gets you intrigued. The next step is really to try it. 30-day demo, just shoot me an email, shoot John an email at ansys@bostonengineering.com, and we'll get you all queued up with 30 days. It really is amazing to see how fast the GPU solver is, and it really is amazing to be able to slide right over into Analyze, use the CPU, get focused on mesh, and not have to rebuild an analysis. So, and just so everyone knows, when they launched it 2 weeks ago, they put in about 2.5, I think, 3 hours worth of tutorials on the Ansys Learning Hub. So a lot of these screenshots we have here are straight out of those tutorials from TopOpt, from modal analysis, from structures, from fluids. So if you don't have access to Ansys Learning Hub, just shoot us an email. We'll get you access, and you'll be off to the races. So with that, any questions? Terry, do we have any questions in the chat, or if anyone wants to jump in?
Yeah, we had one come in from Dimitri. He wants to know if Discovery is going to be a replacement for Workbench.
I find that very hard to believe. Very, very hard to believe. I don't work for Ansys. I don't know the strategy, but I honestly, and this is just my opinion, I don't see that happening. Now, who knows? But I really don't. The reality is, the whole purpose for Workbench, right, is it's more or less a wrapper. It's more or less a user interface for Workbench on top of all of the core physics, right? And that includes getting access to the APDL code, right? So for those of us who are familiar, when you want to dig deep and you want that last 0.01% correlation between your analysis and your test data, you're probably going to write a script or write some APDL snippets in your code to tweak it. That's not the purpose of Discovery. The purpose of Discovery is not to dig deep to the last 1%. The purpose of Discovery in the Explore mode is to say to get you within 15, 10, whatever percent, depending on the complexity of the problem. You slide over to Analyze. That is your true CPU based solver. You're looking to get within, say, 5%. Obviously, there's a lot of additional physics and complexities, multi-phase fluids, nonlinear materials. There's a lot of nonlinearities in structures and fluids that are not exposed in Discovery, and I don't know if they're going to be. That's not the purpose of the tool. The purpose of this tool is to, hit up the first curve, if you will, the first part of that simulation journey. The end of the simulation journey right now is in Workbench, and I don't see that changing, honestly, because the purpose of Workbench is every single possible tool you could want to get to the last, edge of accuracy. So, long-winded answer, slightly opinion-based, but I find that hard to believe.
A couple of more popped up.
Sure.
Excuse me. One of them, let's see. How well does this work with Simulation Live? And while you're answering that, I'll get ready to paraphrase the next question.
Okay. Yeah. So was Simulation Live meaning Discovery Live, or are they asking about Creo Simulate Live?
They're asking about Creo Simulate Live.
Okay. So this is the Ansys tool, right? So Ansys Discovery is the Ansys product. The technology for Ansys Discovery Live, okay, which has been out for a few years, the GPU solving, that technology is under the hood of the Ansys Discovery Explore, and it's under the hood of Creo Simulate Live. And Creo Simulate Live has only been out for a year or two, right? A couple years. And we're just seeing the functionality that's been in Discovery Live for a while make its way to Creo. So Ansys Discovery, the real focus for Ansys Discovery in the new release, one is the new interface. The new interface, the HUD, the SID, the Halo, okay, and this concept of the workflow. But really, what's also really new is the Ansys Discovery in the Analyze phase and getting the CPU-based solver inside sort of the Discovery environment, right? So previously, again, going back, previously this was the Discovery AIM tool. And for those who signed up for this this webinar 2 or 3 months ago when we first launched it, this webinar was originally called Discovery AIM, and we were going to dig into a little bit more about Discovery AIM, but Ansys Discovery 2020 R2 came out, and we decided to focus more on the capabilities in the new tool. But really, what's quite new in the Discovery interface here is bringing in the CPU in the same interface, right? Making sure that we can slide easily from GPU to CPU, back to GPU, back to CPU. Underneath the hood, the GPU solver, that's what's under the hood of Creo Simulate Live. I don't see this impacting Creo Simulate Live at all whatsoever. As Ansys continues to develop the GPU technology, it's going to go into Ansys Discovery in the Explore phase, and then it's going to go into the Creo Simulate Live under the hood.
Okay. All right. The one last question is here. It says, for the webinars, where is the access to previous presentations? And my response to that is that's going to be on YouTube, the Boston Engineering YouTube channel, correct?
You got it. Yep. I think the Creo mold one's going up this week. I don't think we were able to get that one up before this one, but the structure, so CSL, Creo Simulate Live, structures, thermal modal, that's all up there. And again, those are walking through the interface that is in Creo, but if you want to skim that, just understand that that is the technology that's also available in Discovery Live, and also the same technology that's underneath Discovery, the new Discovery Explore phase. So very similar there. We'll probably end up doing some Discovery Explore, maybe in a year or so. We'll refresh these when Discovery's been out for a while. But today, what we really wanted to cover was the new Discovery workflow, the new interface, and then the introduction of the CPU solver in the Discovery environment. So the ability to start to really dig into the mesh, do a mesh sensitivity study, and continue our simulation journey. Whereas Ansys Discovery Live sort of stops at 4, the new Discovery product allows us to continue to go on to more accurate solutions without having to jump into Workbench.
Anyone else have any questions?
All right. Okay. Well, thank you, everybody. Sorry, was that it, Terry?
That's it. So
okay.
I will I'll stop the recording and end this, and I'll send you an invitation for our follow-up.
Thank you very much, everybody. I hope what we showed you was the innovation that Ansys has been putting into the Discovery tool, and hopefully you see some value in it for your team. Shoot us an email. We'll get you a demo. We'll get you into Ansys Learning Hub, and we'll get you moving forward. Thanks so much, everybody. Stay safe. Talk to you soon.